A Universe Sandbox 2 video, and today we're going to be doing another evolution of a custom solar system, but this time, instead of using only one star, we're going to do a binary system. So that means we're going to be evolving two stars simultaneously with a system in a binary orbit. So this will be pretty hectic once these guys get to the red giants, I think. So I think I'm going to go with two Sunlike Stars, so two yellow dwarf, sort of G-type stars, I think it was. So without further ado, let's get into this. So I'm thinking just nothing ridiculously large. I'm thinking the sun itself, and then I'm thinking Alpha Centauri A. So it's a star slightly larger than the sun. So comparison there. Obviously they're the same class as star, but yeah, Alpha Centauri A is slightly larger. So we're going to put them in a binary. How are we thinking distance-wise? I mean, 3 AU. I think 8 to 10-ish, then we can roughly get planets around each star. Let's go 14, so a fair distance. We'll put Alpha Centauri A slightly up there. Okay, so that puts those guys both in a binary, so if we orbit, it looks like the sun may just orbit Alpha Centauri, so let's just see how this works. Okay. So, Alpha Centauri? Yeah, Alpha Centauri A is definitely moving. You can see its trail. So those guys are in a binary orbit here, as we can see. So they're comfortably sitting around each other. Obviously, I don't know why it's not showing Alpha Centauri A's binary orbit, but yeah, at least they're working. Okay. So without further ado, we'll get our first save of this simulation in, so we can set this all up. Obviously, we need to make these stars smaller, since we need to make them like proto-stars and stuff before we make them larger. The mass will stay the same, of course. So we'll call it but birth to death, so BD, and then we'll call it binary, and then we'll call it 1. Alright, cool. So there's our first save. All down, ready to go. Right, so first of all, we need to obviously make the stars smaller, since we're going back in time, so we need to make them a younger variant. So what we're going to do is turn off calculated radius, we're going to lock the mass, and then the same with the sun as well. So let's turn that off, lock the other mass is already locked on that one. Okay, so mass is locked on Alpha A. So we'll make them smaller. So we'll half them down. So the stars are obviously, they start out a lot smaller than they are currently. So that will obviously lower their luminosity as well. So there you go. So half the sun, and then we'll make Alpha Centauri. So make Alpha smaller as well. So we'll start Alpha at 0.2 suns. Obviously the sun is smaller, so we'll start this even lower. So let's go roughly around somewhere there with 0.1. So a dimmer star, less mass. I mean, it's 0.1. I mean, we could probably make it. I mean, it's only 0.1 mass larger Alpha A. So we'll put them around, yeah, 0.1 luminosity there. Okay, cool. I think one thing we'll do as well, just to make it a little more interesting, we'll go with a different background. Let's go with the bright background. And what I want to do here is, I want to edit this. Let's rotate it around. I saw it in one of the recent custom systems. I quite like the design of the background, so we'll give it a bit of we'll take a bit of inspiration from that system. So I think it's the Z one we want to rotate. Okay, so how are we looking? Do we want to? Yeah, okay. Okay, so the galaxy in a different spot. I do rate it. I think it does look pretty cool. Let's try and get it in sort of in the middle. Yeah, so something like that. I'm thinking maybe just a little more somewhere around there. I don't know. I want to make it look pretty. So okay. Oh, all right. So somewhere around there, maybe just a little more. Get the galaxy arm a bit up a bit. Yeah. Yeah, I rate it. Okay. So we've got the Milky Way background there, nice little touch to it. So there we go. So Alpha A and then the sun. So this is the two proto-stars. So I guess we'll call it Proto-Alpha and Proto-Sun. So let's just get those named in. So Proto-Alpha, and then obviously we'll go just Proto-Sun again, since that's our template for this. Okay, so there we go. So we've got two new yellow dwarfs. Well, in theory, they wouldn't be like yellow dwarf stars yet, as they're still smaller, but they're in the early main sequence stage. So these guys have just formed. Obviously, we're going to need a planetary disk around all of these. So again, we'll go ahead and get a save in before we start forming our planets. So let's go ahead and do that. Okay, thank you very much. Right, so obviously we'll do the normal thing. We'll use white rings as an example. But there's two different stars, so the planetary disk could be quite interesting here. So we'll go 0.1 AU. We'll go all the way out to something really large. Yeah, 32, 64. Yeah, why not? Material. We'll go manual color. We'll go white. Add to Alpha A, and then add to the sun. So they've both got a planetary disks that are sort of merged together here. So those rings will probably get scattered around absolutely like crazy. Okay. Cool. So turn all that off. Obviously, this is our first stage of evolution, so no planets have formed at this time. We're at the very beginning of this system, so we'll get a next save in. There we go. Cool. Right. So now we'll let the simulation run for a bit, and then we'll start to spawn in some planets. So again, we'll just go have some random custom objects and stuff that we like. So here we go. So obviously it's going to get a bit laggy with all this stuff going on. Obviously there's a lot of objects in here that are going to be forming. Obviously we can see a lot of objects getting scattered around, but eventually these objects would start to come together and form planets. So it all depends. Look at how the rings are scattering with the binary orbit as well. Obviously if we go to trail mode, we can sort of see more of the action go on here. So both of the planetary disks, they're sort of going to merge in with the two stars. Some of the objects will get scattered, some of them will orbit the stars, and then we'll get quite a nice setup. I think I may have overdone it, but we only spawned the rings in twice. It's just because we've got two sets of rings around a binary system. So yeah, binary systems do tend to be a little slower in when running simulations with this many particles and stuff going on. So, right. Now, on to the interesting part. What sort of planets do we want to have in this system? So we've got plenty of stuff to use here. I do want to bring back our good old classic. I do want to throw LP12 in somewhere. That's sort of just the one that we use in every one of these we've done so far. So yeah, I want to keep up the trend. So where's good old LP12? Definitely one of the favourites. Obviously, we're going to stick to its normal sort of routes. It's going to be one of the objects close into the star. So LP12 will orbit around Alpha A. We're going to spawn it. So 1AU is obviously Earth. We'll put it around sort of Mercury sort of distance. We're going to have it spawning around Proto Alpha Centauri. So there we go. So LP12 is the first planet in here. Not so necessarily saying it would be the first planet to form. Obviously, a gas giants would, in theory. Actually, yeah, let's actually do it let's do it the proper way. So we'll get rid of that. Remember, gas giants, in theory, are the first objects to form. They pick up the most mass and material. So what gas giants do we want to use in here? So, there's so many to choose from. I really don't know. Oh, man. There's just so many to choose from. It's too overwhelming, guys. What should we go with? Let's go with some different ones. We'll try and use stuff that we haven't used before. Let's just use this Gliese 504b. Let's start off with that one. Proto Alpha. Let's put it around. Let's put it around Jupiter distance of Proto Alpha Centauri. So let's put it there. Now, as we're evolving this system, it could mean that objects, when they start to interact with each other, it could mean that they orbit a different star to the one they started around, or they could get ejected by the second star. I think that second star really is going to be playing a lot into here and how this works. So, there we go. Okay, so let's put that one in there. Next up, we'll put, so how large is this object? I want to roughly have our Jupiter equivalent. So this object is 4.12 Jupiter, so it's got plenty of mass. This is probably going to be our dominant object in this system. So we don't want to really have anything larger than that mass-wise. So we'll have a Jupiter object. What about HAT P52b? See, this one we can put around the Sun. So we can have two sort of dominant Jupiter objects in here. But this is probably going to get really spicy once this really starts playing out. So we've got two Jupiters in there. Right. Then I want to have more of some more regular sort of size gas giants, nothing that's ridiculously large in size. So any more gas giants we could use here? I mean, I don't want to use any of the really large ones. Obviously, we can manually edit gas giants if we need to make them smaller, so that's fine. Banded 35, let's just put that in here, see where it ends up. So 6AU around Proto Alpha, we'll put Banded 48, we'll put that around there as well. So we've got two regular gas giants around each star now. I do want to try and sneak in a third one around Alpha A, which is a larger one. So, EBLMBF, why not? I remember this is from, I think this is from one, I can't remember what this is from. Let's place it in. So, we'll place that there. Okay, so we've got some gas giants, then we're going to go with some ice giants as well. So, blue ones, what are we thinking for blue objects? So, so already, we haven't even started with all the planets, and one has already been gone. So it's not coming back. That's natural evolution there, so it's gone. So not have that's completely gone. So oh my god, stuff is already happening. We're not even running that quick. We're only travelling at a few months, and already the gas giants are having major problems interacting with each other. Let's have a look on the orbits quickly here. So what exactly is going on? We can see the stars seem to be going just all over the place here. Their binaries seem to be having real issues. I mean, maybe we won't even get to the red giant phase. Maybe both of the stars will just break apart. I mean, who knows? This could get really hectic. I mean, maybe the gas giants are just too large and they just can't support it. I mean, who knows? So eventually the gas giants could be having problems in here as well. So next up, we'll spawn some ice giants in around some of the stuff. So how large are we thinking? I mean, we could have some objects just orbiting both stars in theory. So let's put another object around Alpha A. So let's just spawn some other ice giant objects in here. But I really don't know how this is going to play out, because it's not often we experiment with binary systems in this sort of level. So this is just going to be absolutely crazy once we really get going here. So we've got some ice giants in here. Yeah, we'll throw one close to the star as well. Why not? Okay, so there we go. So I think we have enough gas giants in here. And obviously we already saw one has been ejected. So Banded 44, it's only 7 masses of Earth, but it's already been ejected. So it's gone. So there we are. Okay, oh, looks like EBLMF as well. Oh, I don't know. This is 17 Earths, so it's not the largest either. Okay, but oh my god, this is really evolving fast. Oh my god. Right, next up onto the rocky planet. So again, we're LP12, the returned object, and we're doing all of these systems just because it looks awesome. So yeah, definitely. I think it's definitely one of your guys' favourites as well. I know a lot of people mention it. I mean, in the comments as well. So where are we here? But where is it? LP12. Where are you, buddy? Well, where's it gone? We spotted it earlier. Where'd it go? LP12. Where is it? Oh dear, I'm really looking like a fool now. Where is it? I honestly cannot find it. LP12. You guys probably screamed at me because you probably already spotted it. Okay, we're just going to spawn it. So it's going to be closer to Mercury distance. We're going to put it roughly around there. So there we go. Then next up, we'll throw one of the sulfur dwarfs, gas dwarfs in here. I do like the sulfur gas dwarfs, so we're going to put a few of those in there. And then onto rocky planets. Okay, what are we thinking? Curio. I'm just going to go completely random objects here. I'm not really going to take much account, but I just want to go with some cool looking rocky ones. So where are we thinking? We already used Pascal before. We had used Muir. We used Nerati. Any more rocky planets? We could build our own as well. Don't forget we can do that. Tista, why not? Let's place you around the sun star there. Any more? Life World, that looks promising already, so let's put the Life World around the sun. We'll put that around 1 AU of the sun, so that'll be an Earth equivalent in there. Captain B, that's a possible Earth-like exoplanet, so we'll place that in there as well. Okay, cool. So I think the inner solar systems in here, maybe, they could be okay, but I think it's the outer solar systems that are really going to be troublesome in here. We can use Coruscant, that's one of the Star Wars planets, actually. Let's put that somewhere in there. We'll just throw some other random rockies in here. I mean, I'm really not, like... Yeah, we'll just go a bit random. Also, a lot of these probably aren't going to make it to the end of this. I'm really not buying it, so... Okay, there we go. And then we'll throw maybe one more gas giant. I mean, I don't know. I think we have enough gas giants. I think they're already having interactions. Obviously, it's not going to stay stable, is it? So there's no point filling it up with just too many. We'll put the bromine world in. That was quite a cool little design as well. Okay, so there we go. And then obviously, like we normally do, we'll throw some dwarf planets in here as well. So we'll go random small moons, and then we are just going to scatter these literally everywhere. Random moon. And then maybe a random rocky planet as well. So we'll throw some few larger extra objects in here. So we've got a rough indicator of planets and dwarf planets that have spawned in here. So this is going to be absolutely mental. We're going to go ahead and delete the planetary disk now. So all of our planets have now formed. And this is what we are dealing with here. So this is going to be... I don't know how this is going to play out, honestly. I think it's going to be really hectic. We'll give LP12 its distinct normal trail colour of yellow as well. So we always know where LP12 is. And then down here, any other objects that have that trail glitch? I think there may be a few. Yeah, we can see this one here, Captain B. But please give you a trail. Give you a nice dark green, my friend. There you go. Okay. Yeah. So we'll just get a full lineup of everything that's involved so far. So this is our system currently. So we've got our two stars, obviously Proto-Star, Proto-Alpha Centauri. So they're obviously new, they're very new stars, obviously not the luminous ones yet. Then we have HAT P32b, so that's on 6 Jupiters in size. Whoa, so this is orbiting the sun currently. So this is our largest one. It's quite a large exoplanet. I've used it in the size comparisons before. Then we have Banded 48, so also another large gassy. Then we have one of the ice giants, so this blue one, Banded 39. Then we've got Gliese 504b. So this one's got a lot of big mass in here as well. So before we run it, I am going to lower the mass of some of these. I don't want objects this large and dominant in here. I did say originally that I wanted this one to be the most dominant, so Gliese 504. So mass-wise, that is still the largest. So nothing larger than 4 Jupiters in mass. So this one's 6. We can't allow that. Let's just lower that down a bit. So 1.68 Jupiters. We'll go more to a more bog standard 1.0 Jupiter. Let's put it there. And then this one was 2.4. So yeah, I don't want anything. I do want this one to be the full-on dominant. So if we go to mass, this is now going to be the most dominant in here by a long shot, even though it's not the largest gas giant. So we've got that one there. Then we've got obviously the ice giants here. We've got a really small one. That's one of the... Oh, that was the sulfur gas dwarf. That's why. So it's still got some good mass in there. Then we have EBOMF. Then, yeah, a nice range of ice giants in here. And then obviously onto the rocky planets. This Christmas one does not look like anything it used to, but it still looks really cool. So there's LP12 in there, the good old classic. Would do like that is a cool one. Also, we need to return off the Earth city lights as always. So where are we? City lights. Yes, please. We'll just put those onto the normal ones. There we go. Cool. Right, we've got Captain B, that's a possible Earth-like world. We'll have to manually add a bit of water to that one. But yeah, there we go. So we've got a nice range of different objects in here. So some of them have got oceans already in the water, so we'll have to see how they work themselves out. I think some of them are just random spawns as well. But yeah, I think we got a real good range of stuff in here. So let's zoom out. Okay. Obviously, we're going to throw a save in before anything gets more crazy, so let's go ahead and do that. So, binary... no, we'll do binary save 3. There we go. Right, cool. So, there we are. Good, good. Come on, game. Let's save. Let's continue. Right, okay, now, let's just let the system evolve for a bit, because I don't think a lot of these are going to make it to the end. We could already see just how hectic this is going to get. So, oh, dearie me. Okay, oh, Gleezer, already... The most dominant object has been ejected straight away. The highest gas giant with mass has been ejected. Now that is interesting. Wonder why that's happened. Maybe it had an interaction with another gas giant. Maybe the other star got rid of it. I mean, remember the star. There's 2 stars. In theory, these are the most dominant objects, and they're interacting constantly. So yeah, gas giant ejected. So yeah, honestly, not many of these will make it to the end. We can just see. It is going to be absolutely hectic in the outer solar system. You can see loads of the outer dwarf planets and outer just planets in general, some of the gas giants. They're not going to last long. The 2 stars are going to have massive interactions off each other. So the only planets that are really safe are the inner solar systems of both stars. So we can see here, Proto Sun, the closest planet, is Life World. This is currently minus 256. Obviously, because there's no... temperature yet. The star is not bright enough. If we go to star zones, yeah, there you go. So you can see the stars are just not powerful enough to have any luminosity yet. The only planet that's probably having any sort of temperature is, yeah, LP12 as normal. So, yeah, it's spawned very close to its planet, or star, sorry. Next planet out is Curio. This one is obviously really cold as well. I think that was an Earth-like planet. We have the Sulfur Gas Dwarf, do like that one. Ups and Bands, another. So that was one of the ice objects. So it's actually maybe a warm Neptune once Alpha Centauri gets going. This one looks really cool. Hat P30. Ooh, this one. This one's having quite an interesting action. So it enters the inner solar system. That could have serious consequences. I mean, it almost gets to the orbit of LP12. Look at that. So that is going to be a massive troublemaker down the road, I think. So there we go. Okay. If we go on trails, you can just see how hectic this thing is going to get. So let's just, there you go. So this is trail mode. So you can see this planet here may have just transferred stars. So yeah, we could have planets that are transferring stars as well. I mean, this is how hectic everything is going to be. So, oh man, this is going to be absolutely crazy. So we can see the Proto Sun is now orbiting Alpha again, even though they are in a binary here. So, oh man, this is, once these turn to red giants, oh my god, this is going to be absolutely crazy. So, I think we can start to evolve our stars a bit. So what we're going to do is, obviously the Sun, luminosity, we're going to double it. So that obviously makes our radius bigger. So we're just going to double it. And then Alpha Centauri A, we're going to double that as well. So radius, yeah, double that up. And then double the luminosity. There we go. So it makes the stars brighter. And obviously that is going to start to have some of maybe some Earth-like worlds down the road. We'll have to just wait and see, really. So how are we doing? Well, there's Coruscant. How's Coruscant doing? Oh, what has happened to this one? Oh, that just looks like a frozen ice ball at the moment. Right. Oh, it just transferred stars. Check it out. Look, transfer of stars. And with that, ejections could happen. I mean, this is just going to be absolutely crazy. We can see the orbits are just not going to be stable at all from all of the outer objects in here. I mean, yeah, look, it's transferred stars again. Look at that. Oh, that is awesome. So, how are we doing out here? I mean, a lot of these are just not going to last at all. So, it's really just a question of time, really, for how long these systems are going to last. I mean, there's probably a reason why binary systems don't have a lot of objects in reality, and this is probably why, because a lot of them just don't last. They just get ejected, interact with the other star, and just get gravity assisted out of the system. But we can see that's probably happened with a lot of these already. Or the orbit mode, there's no orbit. I mean, look, they're not orbits, they're just trails. So, yeah, look, a lot of them are just being sprayed out. So, the only real action is going in the inner solar systems here. So this is where the most action is going to be. So we've got a completely different type of system here. I think for another series of this, we'll probably have to do binary systems where the stars are a lot further out. Maybe more massive stars just to make it a lot more stable. But yeah, we're doing 2 Sunlike Stars, which I think was a good start for this. So yeah, we've got a completely different way of this system evolving this time. So yeah, really, really cool. And I hope you guys are enjoying this so far. So yeah, this is good stuff. I think this is really, really cool. So again, we'll pause it and we'll have some more evolution of the stars. So LP12 is already up to 170 degrees here, so looking pretty cool. Right, how are we doing? So Proto Alpha. Okay, so luminosity, we're going to double it up. So we're going to have massive jumps in time. So we're going to double the sun up as well. So 0.4 suns on there. Obviously, Alpha is slightly larger, so in theory, this star will age maybe a tad quicker, become a red giant a little faster. So, yeah, right, cool. And remember, I'm trying to make this as realistic as possible from the knowledge I have of astronomy and star evolution and stuff. But obviously, it's not going to be 100% accurate. We have put fantasy in here a bit just to make it a little more interesting. So please take that with a grain of salt. We're not going for the most realistic scenario here. We're just doing it for a bit of fun. But I'm trying to implement parts of realistic stuff in here. But obviously, we have put some maybe a little too many objects in here. But yeah, we like to have a little bit of fantasy to make it a little more interesting. So yeah, please put that as a precaution. If you are thinking this is entirely realistic, because we have put a bit of fantasy in here, a little bit of extra to make it more interesting. So right, there we go. Let's continue. So yeah, it looks like Christmas that looks like it's been ejected. That Christmas object that is definitely completely gone. That is definitely not returning. So we can see roughly the main objects. I will highlight the main objects actually, so we can see HAP 52b looks like to be the biggest gas giant going on now. So we'll give that enhanced. So basically all the important objects I'll give enhanced colours so we can keep an eye on them. So if they get ejected, we'll know about it. So there we are. LP12 and then Curio in here. This world could possibly be a world for life at some point, is my guess. So, okay, there we go. So they're roughly all the planets that I think are important around the Alpha. And then around the Sun, obviously we have the life world. We've got Tista here. It looks like the objects around the Sun are more stable at the moment. So we have Tista, so that one's there. Then we have Captain B, that one's green. And yeah, I think that's roughly it. And maybe this one over here, if you want to have a long stretch, it looks like one of the random generated objects. But yeah, I think those are roughly the main objects we want to be keeping an eye on. Because I think all the other ones out here, I think they're just gone. I mean, they're not returning, are they? So, okay, let's keep it going though. Right, here we are. Right, let's see how this evolves. So, yeah, once these stars get bigger and more luminous, their habitable zones will probably merge once they get bright enough. So this will be really interesting, I think. All ups and bands, so we can see a transfer just happen between the stars by the looks of it. So that's around the Sun now. So, okay, cool. We can see that yellow orbit as well, Ubitus over here. That one's having some problems. But yeah, I think we can safely say that these objects are all gone, so we can just get rid of them just to get rid of the bads. A lot of the bads just to get rid of the trails. But yeah, I think all these objects we can pretty much account have been ejected. They're not going to be returning. So there we go. So there we go. It just helps us with the lag. We see the Christmas object is just long gone, so we don't need that in here anymore. But yeah, it just stops all of these weird orbits from happening. Because yeah, they are clearly not returning. So you can see they're on a constant distance here. They're not coming back. So yeah, they're definitely gone. So you can see they're completely just going in the wrong direction. So they've been just knocked off of this. They'll be rogue planets now. So I'll keep the few that are hovering near the planets because there's still hope that maybe they return. But yeah, we'll keep a few of the remaining objects in here, the closer ones. But yeah, here we go. So let's slow things down again. So we can see that Uranus one is really having problems now in here. So yeah, that is not looking good. So all of these objects, I'm really not seeing much happening for them. It's the main stuff is all happening in here. So anything further out than the yellow one, yeah, I'm not seeing much happening. We can see ups and bands, another star transfer. That is really, I really like that. I think that's a really cool little thing that can happen in these closed binary systems. It's planet transfers, star transfers, however you want to call it. Literally swapping stars. That is, look at it, it's doing it again. Look at that. Oh, that is so cool. So it really does raise more anomalies and more. Yeah, you won't be able to predict what happens when the planet transfers. You don't know how its orbit's going to be. You can see that, look, both planets there. So that ups and bands, that's a gas giant, remember. And then HAP P32b, that's the largest, or one of the larger, the only large object remaining, really. So if we have a lineup, we can already see that we have lost a huge amount. There's only 2 gas giants remaining. Remember, we had like a good 6 or 7 originally. And rocky planets again. Yeah, we lost a huge amount of rocky planets. There was a lot of planets of water on them that have been lost. And that's a shame. And that kind of, I guess that's kind of a lesson for reality, that it just shows how rare a scenario has to be for an Earth-like world to exist. Anything could go wrong. There's so many things that could go wrong, and we've had quite a good example in this binary system. For instance, maybe that's why Earth-like planets may be a little more rare in binary systems. Maybe this is a rough example. I mean, I'm not saying it is, but I'm just suggesting, possibly, that, yeah, that just a scenario like this would, in theory, have less likelihood for an Earth planet. So there we go. I want to see this Curio planet warm up. This is probably the best contender for life currently. Obviously, LP12 never is. And all the other planets don't look too hot. But this is the only planet that could possibly have life at one point. So maybe we'll give it a slightly more friendly looking atmosphere. So instead of being a toxic-y yellow, we'll give it more of a bluish, whitish, sort of earth-like-y sort of shade. A little more friendly looking. Clouds, we'll give it maybe some blue clouds. So try and get that earth-like conditions going on it. So there it is there. Obviously the surface colours I think are a little too extreme, so we'll darken those down to a more of a brownish shade. But I do want to see this world. I think this world has the properties to do it. So I do want to see this one melt once we get a bit of temperature. Because obviously if we reset it to 0, it just can't do it at the moment. So this is roughly where we're going to be. And remember life world as well. This world could possibly do it at some point as well. If we look underneath all of this ice, snow and ice. That's what it looks like underneath. This world could possibly do it. You can see it's looking good under there. Obviously, again, I don't want it looking too green at the moment. It obviously needs to build up a bit of a temperature before it starts to look green. But yeah, this world could possibly have so it's probably, these two are probably the top two that we're going to be looking at for Earth-like conditions. But it could go all completely wrong for them. Remember, to get an Earth-like world, it has to be in the exact correct place at the exact right time without having any interference from the other planets. So, yeah, it could be a disaster or it could be a success. You never know with these sort of systems, especially these binary ones. Because obviously we know how rare Earth is. Rare is a very, very rare anomaly currently with our current knowledge. So obviously having two in one system is obviously very rare for a system like this, I think, as well. So how are we looking here? It looks like Ups and Bands is in serious trouble with its orbit at the moment. I mean, look at that. I mean, that is not looking good at all. It all depends on the gas giants could really, really ruin this, I think. The gas giants could really play into part of ruining the rocky planets. So it looks like both of the possible Earth-like worlds are in orbit of the proto-sun, I think. Oh no, hang on, we have Life World. Where did the other one go? Hang on, let's have a look. Hang on, where did... So we have the sun. Captain B's an Earth-like possible world. So where has Life... So we have Life World. Where's Curio gone? Curio? Oh, so, okay, no, I was just blind. I'm really blind. Never mind, ignore me. So, Curio's there. Okay, cool. Right, so, how far is Curio from the star right now? So, Curio is 1.13. Okay, so it's a little further than Earth, so we won't be seeing this. So, this is roughly a Mars orbit at the moment. So, the main object we are going to be focusing on is Life World 1. This is closer than 1AU, wasn't it? Or around 1AU, wasn't it? Yes, so it's actually closer than 1AU. So this is where the life will start, or this will be the first world that could hinder life. So, okay. Right, I think it's time to evolve the stars to the present day now. So we're going to have, we'll go up to, no, I don't want to do that. No, we'll go, 0.8. Okay, so that's not at its maximum, or the sun isn't at its present day yet. And obviously at Alpha Centauri, we're going to buff you up. So this will get to its present day. So 1.51, that's actually that's obviously evolving a lot faster than the sun is. So let's see how, maybe Curio will warm up first. Let's see how it does. So 0 degrees. Can it support it? No, it can't. Atmosphere. We are allowed to play with atmospheres in these scenarios. So how's atmosphere doing on this? Surface pressure is 0.6. So we'll put that to 1. We'll go 0.9. No, not 10.9. No, 0.9. There we go. Cool. Infrared will increase. Albedo will lower. Okay, so that should give it some nice chance to warm up. No, it still won't have it. Okay, so the star still needs to warm up more for this one to work. So here it is. See, it's still frozen. No chance here yet. But yeah, there we are. So it looks like our system may be sitting fairly comfortable now, I want to say. It looks like they've got rid of all the objects that they don't want to include. Oh, what was that? Oh, no, let's just pause it. No, that's just the orbits being weird. Yeah, okay, there we go. So it's just we don't need these anymore. These are not returning. So this is our main sort of system currently. And yeah, there's that bromine world that we lost as well. Okay, so this is now our system. So we've got way less planets, but this is roughly the main objects are these ones here. And obviously that yellow one is really hanging on for dear life. But yeah, this is the system that will probably take us to the very end of this now. So there we are. Obviously the stars are already at their present day forms roughly. So I think what we will do is put the sun just straight up to 1. So there we go. So the sun is now at its present day form. We can see it's all got its correct stats. And obviously Alpha Centauri A is a little further ahead with its stats. But yeah, there we go. So they're roughly sitting where we want them to be. Captain B, still an object that could have life, but it's too far away currently. I mean, look at its orbit. I mean, that's not looking good. It doesn't get the stuff it needs. So let's give it should have some water on it. This one's going to be an Earth-like world. So it looks like it needs an atmosphere. So we'll have to manually add some bits onto there to give it what it should have. Because even though it's too far away, I still want to give it all the materials it should be having. And remember as well, it's getting light from 2 stars. So this could really have some interesting possibilities when these stars get hotter, and brighter, sorry, I should say. So, yeah, we'll do. I want to get in. Is an atmosphere? Where does atmosphere go? Atmosphere mass. Yeah, Earth ATM. Around 1.1. There we go. So that world will be in the distant future. This world will warm up. I mean, this is probably the equivalent to one of Jupiter's moons at that distance, roughly. So the stars are going to need to be in the red giant sort of area for this one to warm up. But yeah, there we go. So that does it for part 1 of evolving a binary system from birth to death, guys. So I hope you've enjoyed it so far. Obviously, any feedback, suggestions and stuff for this system, let me know down below in the comments. But yeah, there we go. So there's a obviously the amount of objects we have lost is absolutely crazy. I think we had a good amount of objects at the beginning. We have lost so many due to this star. I think that both of the stars is the main problem, because as we saw from the previous 2 systems we've done, we kept a lot of the planets throughout, but obviously with 2 stars in here, and obviously those gas giants pushing each other around, the only real gas giant remaining is this one. So, yeah, the fate and good luck has got this one through the development phase of the system. So now we're sitting roughly with the comfortable planets in the system. So, yeah, there's only 2 objects left, ups and downs, the ice giant, and then we had the regular gas giant over there, Happy 32b. So, yeah, they're the only gas objects remaining pretty much. So yeah, pretty cool evolution. I think we've had completely different scenario, completely different results to the previous episodes. So yeah, I really hope you guys have enjoyed it this far. So yeah, make sure to leave a like down below. Let's see if we can go for 50 likes on today's video, guys. And obviously stay tuned for part 2 of this series next week. And yeah, maybe part 2 will be for the finale, because obviously we've ran the simulation quite fast. So maybe it'll be in that red giant phase next episode. But yeah, stay tuned for that. And yeah, guys, make sure to subscribe as well. Help us on the journey to 22,000 subscribers now. A massive thank you for 21,000. And also, I'm planning my 20,000 special actually next week, so stay tuned for that as well. I put a vote poll up, so if you want to have a look into that, check out the community tab on the channel. But with that all said and done, guys, make sure you have a great day. Stay safe out there, and I will see you in the next video. Goodbye.